APL interpreter didn't have a true garbage collector. They had a reference counting mechanism, and ours, I believe, was the first one who had a garbage collector.
Well, I think we're ready to start here. It's 12 o'clock Central Time, and so I think that if you're okay with that, we'll go ahead and start. So, Brian or Peter, did you have a card deck you wanted to start?
That should be already up there, mate.
Okay, I'm not sure.
You see the LIDNUG slide that's on the screen in front of you?
That's it?
Yeah, well, if you look down in the bottom left corner, there's a couple of blue arrows. It'll say 1 of 5.
Or you can use control and the arrow down.
Oh. Okay. All right. I don't see that.
Okay, recording's kicked.
I don't see any controls to control starting the presentation.
Just press control and arrow down.
Oh, control arrow down. Okay. All right. Let's go through the slides. This is a presentation with Patrick Dussud, technical fellow. He's the lead on the .NET CLR and the lead architect on the .NET framework, and he worked on the GC, the garbage collector, and now he's working with Azure. Let's go through the rest of these slides first. Let's see. We've got Phil Wheat coming up and Avi Cabell coming up in May. We've got a whole bunch of interesting URLs here. I'll bring this back at the end of the presentation for you. We have a nice Facebook presentation. We're on Twitter. If you're doing Twitter, then follow us, and we'll try to follow you, and we can tweet about these presentations, and you can get that information directly through Twitter. Join our LinkedIn group if you're not already a member, and participate in these discussions, because what we're going to do is we're going to start off with the discussions that people ask questions in the discussion forums, and then we'll move to the questions that people are posting with the Q&A. There's our email address. You can see info@lidnug.org. Our team, I'm the last one on the list there. Dan Wygant, Inbar Gazit, Brian Madison, Peter Shaw, Asit Athol, did I say that right? Will Kelly, and myself, Dan Wygant. We've got moderators Isaac Bragg, Abraham, Yogesh Bang, David Haney, and Raymond Reyes. You can find our events up on lidnugevents.eventbrite.com, and you can see a couple of our RSS and iCal feeds. One of the things I'd like to say is thanks to all the LIDNUG people that are attending, and to the managers and moderators that help make this spam-free environment. And we've got over 46,000 members. We're one of the largest .NET user groups in the world, and we have some of the most kick-ass people here presenting, and one of them is here today, and this is Patrick Dussud, one of the guys that kind of you never realize that this guy basically gave us .NET, and the things that he's done in the past decade at Microsoft especially. I'm just terribly happy that he's given this to us. This has been the most joyful time of my life, being able to program and manage code personally. And so for the first part of the presentation, Patrick will answer questions off the discussion forum on LinkedIn, and then at 10:30, I believe Charles Horries from Channel 9 will come in, and he'll handle all the questions in the queue. All right, so let's go ahead and start off. Patrick, would you like to say hello?
Sure. Thank you very much for inviting me, and I'm happy to be here. And if I can say a few words about my current job. Microsoft is the company that I've stayed the longest. I've joined in '94, and interestingly enough, I haven't moved around very much. I started in the VBA group right before Win95 and VB4 shipped, and then I worked on VB5, and as a Christmas project with 3 other friends, we wrote a JavaScript interpreter, a VB script interpreter, and that was done over the Christmas holidays to integrate that with IE because Netscape had JavaScript in their browser. And then Windows 95 was winding down, and some key developers of Windows 95s were peeling off of that development, and one of them, Michael Tutongi, who is a good friend of mine, said, "Hey, you know what? There is that new Java language coming out. Hey, what do you think? Hey, what can't we write our own virtual machine for this?" I said, "Okay, that's fine." So the same friend who started the JavaScript and VBScript, we started, and by the time we signed an official contract with Sun, we had our own implementation of the Java VM. We didn't have our own class libraries, we just had the VM. And then we developed that, and when our relationship with Sun got strained, we decided that maybe having a more general execution engine was the right thing to do. That was designed from the start to be multilingual. And so Mike Tutongi and I started the CLR group. And we were joined by the team who was very interested in metadata representation for programs. So they contributed the metadata side, and we contributed the runtime execution side. Those teams were merged, and then we, a few years later, we came out with CLR 1.0, and I stayed on since then, mostly because I'm having a lot of fun. Second, because I don't like to leave things halfway done, and I believe we still have a lot of things we can improve in the current CLR. So I will stay on the CLR as long as I believe there are things we can improve demonstrably. So that's my introduction. Please ask questions.
Right, Dan, have you got the page up, mate?
Oh, I'm sorry, I was on mute. Sorry about that, Brian. Patrick, I've got the first question here from Radek Kearney.
Okay.
And his question is, will we ever see multiple inheritance in the CLR? This is the only feature missing to make it complete.
That's correct. Yes. So that's a hard egg for me. I like multiple inheritance. On the other side, it's hard to implement quickly and not to slow down the whole CLR as a result. Essentially, the basic idea is that right now, when you call a virtual method onto an instance, the virtual method code knows exactly where each of its members are, the data members of the instance, because they're only one. So you start at the beginning, that's the top, the base class, and then you add on in order as you derive, so you add the derived members. So there is an ordering that is known. When you have multiple inheritance, then you bring another piece, and this piece has to be somehow interleaved with the main inheritance. As a result, you don't really know statically when you compile a virtual method where the members are going to be. So you need to have at runtime to pass an offset that is expected by the method. So if you suppose you have two base class, you have base 1, base 2, when you compile a method that is off of base 1, then it will expect some, it needs an offset to find out where its base 1 members are in the whole instance, and same for base 2. And that's what we had in Lisp when I was working at TI, both on flavors and the common Lisp object system. We had multiple inheritance, and we had these, what we call mapping tables, which were offsets, and would give the starting offset of groups of members. And that's something that is doable. Unfortunately, it's another indirections, and indirections are very expensive, as you guys know. They will, put register pressure. They will put TLB pressure. It's cache pressure. It's expensive. So far, we try to strike a balance between things that are efficiently implementable and bring, comfort to the programmer. And we draw the line so far at multiple inheritance. It doesn't mean that it's something we'll not revise at some point, but right now it has been off the table, and it's off the table for the next version.
Okay.
So it's disappointing, but hey, what can I do?
No, that's understandable. So basically, you're saying that there's a whole lot of complexity. There's a whole another level of complexity involved. Let me go on to the next
that you lose.
Yes. Let me go on to the next question here. Let's see. Now, Peter Shaw asks, my question for Patrick: where do objects go when they die?
Well, they get reclaimed. Their space gets reclaimed. And that's what the garbage collector is all about. And so far, we've had several generations of the collector in the .NET CLR, and we've managed every release to make progress towards the ultimate goal I have, which is you don't notice a post time ever, and you can handle several gigabytes, several dozens of gigabytes of heap. And we've made steady progress towards this goal, and we have few more turns of the crank we will make in the future. But that's what I've been doing for a long time.
Okay. I went back and reread the questions here. I've actually got a hidden question, and it's something that I had read online around January, and it's a code name Red Hot. Can you talk about that at all?
Hold on, I was slightly distracted. Charles came in, so now he's here. If you could repeat the question.
Well, I had a question about Red Hawk and in general about the future of, how do I put that? Let's see, let me just read what I wrote. It would be nice to know what's coming regarding the new XAML engine or engines from one into the other, Win 8, Metro, WP, Windows Phone 8, WP8 that is, and beyond. So there is one of my wishes, or what you could speak to. So I had heard this thing about Red Hawk, and I'm wondering if you can talk about that. It seems to be something implying the combination of Windows Phone 8 and Windows 8, and the concept of having a common set of kernel. I don't know, DLLs. I don't know if it's the whole thing or just some commonality, kind of like with Silverlight.
So first, it's not what Red Hawk is all about, but I cannot talk about Red Hawk.
Okay.
It's something that is very internal and not developed enough, so we can talk about it. So we can talk a little bit about the XAML thing. So the XAML, we try to be very compatible between Windows 8 Metro and Silverlight. And then we try to be compatible between Silverlight and WPF. There are some differences between WPF and Silverlight because WPF is a lot more complete and evolved framework that unfortunately then requires more resources. So you can think of Silverlight as a lightweight, bare-bone graphics library, and by far we try to make the XAML pretty common between the two. And then Windows 8 came along and they wanted to have a XAML-based UI library, and so the team who did Silverlight also did this library, and they, by default, unless there was a pressing reason dictated by the OS for why the model was going to be different, the model is the same. And if you look around, there are several people who have ported Silverlight code to Win8 between the phone and Win8. So there are strategies to bring the XAML side to have common projects and have the XAML being compiled in both contexts. That's certainly not as well developed as we'd like to be. We will improve the tools over time, but the intent is to converge on the XAML story. The part where we are the furthest apart right now is in what I call the application model, which is how you start, how you change page, that sort of things. Win8, Silverlight, and the phones are a little bit different, and there are good reasons for that. Silverlight was designed to be an in-browser experience, and so it picks up on the navigation model of HTML as much as it can. The phone is an out-of-browser experience. It's a device experience, so they had something slightly different. And then Windows 8 is a holistic experience as far as the OS is concerned. So what was paramount there was the uniformity of experience, regardless of which technology for UI you are using, either HTML5 or XAML. And so the model had to be changed a little bit because Windows 8 wanted the best experience they could, therefore they reflected their best effort for the app model, and that's why it's a little bit different from the phone. But in general, we strive to make the XAML experience as common as possible, and when it's not common, we have good reason for it, the reason being generally dictated by the platform and the form factor.
Great response. I'd like to go ahead and thank you for all the people that posted to the LinkedIn forum, and those questions have been answered. If you came in late and missed those, we'll have a recording, and it'll probably be posted a few hours after this. You can, I believe, find them up on YouTube. And we've got another person involved with this presentation, and I'd like to go ahead and introduce him and let him read the questions from the message queue. We've got a few in there right now, and I'm going to go ahead and introduce him. His name is Charles Torrey. I think I said that right. Didn't I say that right, Charles?
That's me, yeah.
And he's original member of the Channel 9 team, a software developer and a software evangelist. Most recently, coordinated Lang Next 2012 and invented the Going Native event. He's interviewed Patrick a few times on Channel 9. Yeah, I saw some of those. Those were, that's pretty good. I appreciate that. So I'll go ahead and hand that over to you. And if you members have any questions, then all you have to do is look up in the top menu there. You see Q&A, and you just click on that, and it'll bring up a panel, and you can type in your question on the Q&A part and hit enter, and there it goes. So actually, I think I'm going to go ahead and ask him a question too.
Great. Cool. So there's no questions yet, but
yeah. Click on the Manage tab.
Manage.
Yeah, you'll see all the questions. And just to reiterate, so you know, when you've answered a question, you can pick any of the questions you want. But when you've answered one, just go ahead and hit the check mark there, and one of the LIDNUG managers will remove it from the queue, so you won't see that after you've answered it.
All right, so let's take a look at some of these questions. Well, there's a historical one. You know, sort of what the vision was of the CLR.
Yes, so I spoke to it a little bit in my introduction.
Okay.
You guys want me to elaborate, or did you believe that what I said was enough?
Entirely up to you, Patrick.
Okay, well, we can go. It's up to you. Let's look at some more modern questions. So. All right, let's go ahead and, this is more of a personal thing.
Yeah.
So let's go ahead and answer that.
Yeah.
All right, so we're going to talk about, what languages that so sort of historical one, Patrick. The question from Peter. What languages and environments did you study before developing the CLR? Which of those you studied were most influential in the design of the CLR? So your background and
yes, so
CLR.
When I was in school in computer science, we had a team who was interested in runtimes, and they were interested in APL of all things. So I worked on one of their implementation of APL, and I've always been fascinated by managed languages. By manage, I mean there is a runtime that ensures type safety for you, and so your program either will generate errors or will work but will not crash randomly because of another piece of code that was poorly written. So poorly written code essentially fails predictably, as opposed to generate weird type errors. So I worked on Lisp a lot. I worked on Lisp in Schlumberger, where I worked on a OS that was based on a DECstation Lisp implementation. Then I worked on TI, where I was responsible for all of the system internals, which is essentially the OS minus the file system. And again, it was runtime. And I worked at Lucid, where I worked on a C++ IDE, which was trying to borrow most of the feature of Lisp machines environment brought to bear for C++. And then I joined Microsoft, where I worked on VB, VBScript, JavaScript, and Java. And so I had a fairly large and wide background in managed languages, I think a lot of them had an influence over the CLR. When we started the CLR, we decided that CLR was going to execute more than one language, unlike Java. To be fair, Java was our main competitor when we started the CLR. So C# was aimed directly at Java. We had that in our sights. And the CLR did its best to accommodate the language, but VB was certainly a prime target. Interestingly enough, we also had Fortran and COBOL, and we had a customer implementing COBOL. It was, who was the company implemented COBOL? I don't remember. We had maybe Hitachi or some.
Okay.
They had their own COBOL implementation on top of the CLR. So certainly having a Lisp background which had the most sophisticated object-oriented system gave me a quite to think about. And as I said before, when I did consider multiple inheritance, because we had that, I had experience working with it. However, we wanted to be as efficient as possible. I believe that Lisp was very ambitious but not efficient enough compared to C++, and that's one of the reasons for its limited adoption once graphics workstation based on C++ appeared. So, yeah.
Okay. So let's talk. So Pavel's question about CLR GPUs all the rage today, understandably, we understand why that is.
Yeah.
So what's the story with managed code and GPU?
Yeah, so the GPU essentially is mostly a single instruction, multiple data, so it does vector processing, and it's the processing power is ramping up faster than normal CPUs. So you get more and more value. So it becomes more and more interesting to execute vectorized code there. There is a research project, I think it's still out there, that you can get that from MS Research that you can download and will work with the CLR. What they do is they have extensions for vector classes, and then they compile these vector classes to GPU code and execute there. Or if you have an x86, they can compile it to an x86. And that was an interesting research project. That's something that the problem was always that the GPU is not is a second-class citizen on as far as the OS is concerned. It's very hard to mix and schedule time on the GPU that doesn't interfere with the graphics side. That's getting better and better, and at some point I believe that it's something that some form or another we will be able to deliver at some point. It's something that we are thinking about. Certainly it does make sense for vector operations, and at one point we were very interested in Intel. Intel had a project where they had a processor that had on the same chip, they had a lot of small x86 cores, and they had a lot of them. And certainly for us, that would have been ideal to run on, because we know how to generate x86 code, and so we could have used the vector unit this way. This project hasn't been realized in product yet, so we obviously we can't use it, but we believe GPUs are evolving, so they are more and more complete in terms of scatter, gather, and this kind of operation that are essential for general purpose computing, vector computing. And at some point, we probably will have an option to execute some code there.
Excellent. That's good. All right, so we're going to mark that as red. Okay. What about this guy?
Yeah.
All right, so Adam asked a good question.
Right. So, yeah, LOH fragmentation is something that we know was a problem, not so much because of the 32-bit versus 64-bit, but just because of the fact that we don't compact the large object heap, and we had a pretty naive allocator. So in CLR 4.5, we have a much better, that's 4.0 or 4.5? I believe it's 4.5. We have a much better LOH allocator, and our test and the use case where we had problems before, we saw a dramatic decrease in the fragmentation. So we are actually, the results were so good that we decided not to invest in a compaction phase for the large object heap. It's something that we may revise in the future based on external data, but our internal data and the early partner we worked with indicated that it's not necessary anymore. But we welcome feedback on that. It's hard to tell, but so far we are very optimistic that the problem in large is solved.
Cool. Good question. All right, so not just also GPU, but SIMD. Okay. This is a good one. So what is the criteria used to decide to mark the class as sealed in the CLR? So when you make a consumable object, it has to be sealed. Why is that?
Well, no. Sealed is the fact that you cannot derive from this object, essentially.
Okay.
And so we do that mostly for security reasons. What's happening is that if you think of a class hierarchy, and every time you derive and you override a virtual, you essentially, if you like, inject some external code into that class. If you believe this class belongs to you, that's your ecosystem. For example, take anything like a network, network class. And if you make it unsealed, you will allow some code you don't control to modify its behavior, and sometimes it introduces security, especially for low trust, could introduce some security, a vector of attack there. So if you want to execute untrusted code that derives from one of yours, then you'd better have all of the virtuals sealed. So I remember in CLR 1.0, we had very few things sealed, and then we did a massive security review, and we discovered that unsealed virtual were actually a massive threat. And so we scrambled and we did a whole bunch of threat modeling, and then we sealed all of the ones that we didn't have a very strong case for extensibility. So in general, when you think you write a framework and you are going to allow untrusted code to extend this framework, then usually you have to consider every unsealed members to be a threat.
Great. So we're going to that one. Great. So interesting. So let's talk about this. This is from Matthew Kane about the CLR. Can we let's read the questions. People know it's so the CLR 1.0 beat JVM in performance. Now, by certain real-time world benchmarks, the most performant JVM implementations beat the CLR. So is that, first of all, is that true? And
so we believe that's true for numeric intensive code. So IBM in particular has invested a lot in the floating point code generation, where we hadn't done any work. So we have, for example, we have no evidence that anybody come close to us in terms of garbage collection performance. For example, on servers, our workloads work leaner than the competitors in terms of floating points and vector operations. We are not very good compared to the state of the art. That's something we know, something that we hope to address sometime in the future. We are worried about it. And as I said, both SIMD, floating point, is something that a good compiler ought to be doing right. And so something we will do in the future.
Excellent.
All right, so that one. Here. GC question, right? All right, so can you tell a little bit about the evolution of the GC, which has certainly evolved since your days in JavaScript, and managed code in terms of historic bookmarks that changed everything? That's a little bit confusing what that question means, but I guess maybe you could talk about the evolution of the GC, where we are today and where it was.
Right.
Okay, great.
So the CLR 1.0 came out with two flavors of GC. So first, the Microsoft Java VM had only one flavor of GC, which was for the workstation. And CLR 1.0, I wrote that part. So when I wrote the garbage collector for the CLR 1.0, certainly I knew where we were coming from. And right at that time, ASP.NET was a new workflow for us, and it was executing on MP machines, and MP machines were starting to appear at that time. So I looked at the problem and discovered that there was in state of the art in GC, they had several attempts to do multiprocessor garbage collection, but they were fairly inefficient compared to the unit processor one, because they had fairly low-level synchronizations during collections. And I thought about the problem and discovered that there was a significant improvement you could make if you consider that the workload is uniform from one request to the other. So you consider essentially the classic server scenarios where you pick up requests, you execute requests, and you pick up requests on whichever processor is available. But if you look, all processors are pretty doing uniform work. And so I took advantage of this and did an architecture where there is minimum synchronization going on between the processors while they are doing the garbage collection phase. And that was so 1.0 had the stop the world server GC and a first generation concurrent GC. Then after that, the next major was so besides performance improvement and scalability improvements over time, we had a second generation of concurrent GC that we call background. So the innovation there is that up to now, when you were engaged in a concurrent collection, a large concurrent collection, when we collect the generation 2, you couldn't collect Gen 0. So the garbage would accumulate and the memory would shoot up because you don't take advantage of the fact that most of the new object you create become garbage very quickly. And then when the full collection was concurrent was done, then you could resume the collection of 0 and 1. So the next Gen 0 collection was getting rid of a lot of garbage at this point, and we're introducing another hiccup. So now, with the background collection, we can have a long-term Gen 2 collection going on, and we still collect on schedule, collect the Gen 0. So there is true background. There are essentially sometimes there are two GCs going on at the same time. There is a Gen 2 collection, and in the forefront there is a Gen 0 or Gen 1 collection. And the two garbage collectors essentially handshake, so they keep things straight. That was a major improvement for handle large heaps and yet have very small poses and have a good use of the memory, because we would collect very aggressively still the Gen 0. And it was good enough, so we decided to introduce that on the server side as well, and it's 4.5 as background GC for servers. So those were kind of the major phase of the major generations of GC. And certainly, it's not the last. We have some other turn of the cranks that we believe will help, all going towards the goal of having larger and larger heap with smaller and smaller poses, or certainly having more predictable poses, if you like. Our goal is not to have microsecond poses, but have sub-millisecond poses that are regular and not have larger ones.
So one question out of
Yeah,
that would
yeah.
be, when you were in the early days, did you ever think about, because reference counting like we have in Windows 8
Yeah.
is a form of garbage collection. It's not generational stuff you do, but did you ever think about that model?
We had so many times this question, and when the problem is when those two worlds collide, and when I don't know how many months senior people wasted time on trying to find a solution to make the two in perfect harmony, but essentially the reference counting is very crude for two reasons. First, because there are some graphs that it can handle, and if you certainly have cycles, then you're screwed. The second thing is that there is a large burden on each instance to maintain their own reference count, and the fact that you have to maintain a precise reference count each time introduces severe problems when you have multi-threading involved, because you need to protect the reference count. Adding and removing reference count has to be MP safe, and that introduces yet more problems. The nice property of reference counting is that it's fairly incremental, since it's you don't need a global guide that will tell you, hey, all those objects are dead, all these objects are not dead. So it's certainly by default very incremental. And there have been some research done to try to introduce reference counting for the Gen 2 heaps, the heap that contain most of the old objects, and try to see if we could kill incrementally some old objects this way, and then when cycles get introduced, then you give up on that, and then at some point you kick off a background collection. That's certainly an interesting way to go. It's very different from the COM reference counting that has very limited capabilities. But it's something that is interesting to think about.
Sure, kind of the hybrid
GC. All right, so okay, so this is interesting. So there's the unsafe keyword in C#.
Yep.
And the question is, Sean is interested in knowing more about how the CLR handles what is deemed as unsafe code. Does the garbage collection not handle any of the objects within the unsafe blocks? So that's really
right. So there are two broad categories of unsafe code. There are unsafe code that do not threaten the type safety directly. For example, you could say, hey, I'm going to be unsafe and not check array bounds. And the code is certainly unsafe because if you exceed the bound, then you are going to access random memory. And so it's unsafe in this respect. You could violate type safety, but you don't have much effect on the GC side. And then when you have a pointer, so the fixed keyword in C# allows you to extrude a pointer off of an object. And during the execution of that code, while the pointer is live, the pointer will not be updated. Therefore, the object that is there, that is pointed to by that pointer, cannot be moved. So when GC happens, GC will notice that there are fixed statement executing and will not move the objects that are pointed to by fixed. So the effect on GC is fairly moderate, is about the same effect when you have a native call to, and you pass a byte array or a string to the native call. We don't copy the strings, we don't copy the byte array, we just take a pointer and pass it to unmanaged code. While that code, the unmanaged code is executing, then if there is a collection, we will notice that we have an outstanding native call and we pass some objects to them, and these objects will be pinned, will not be moving around in memory. So it introduces a little bit of inefficiencies because it introduces what we call a sandbar, if you like. It's something that object has to go over in order to be compacted, and this object itself will not be compacted, but it's not very critical.
Great. All right, so I'm going to get rid of that one. No, okay.
Morgan to Raspberry Pi.
So Dave Baker asks, have you played around with Raspberry Pi?
No, I have one on order, but I haven't received it yet. I've had on my desk for a while. I had the TI Beagle, which is very similar. Those things are pretty cool. I mean, they are ARM chips, and they are good ARM chips. Certainly, we care about ARM chips. We have some on the phone. We will have some on Windows 8, and CLR will work on Windows 8 on ARM chips. So yes, that's something that I care about. Something that the price point of the Raspberry is what may be a game changer for a lot of hackers and young people wanting to learn about computing down to the metal. I mean, I remember, when before my college days, I built, computers from scratch using, CPUs off the shelf. I played with, Apple IIs, TRS-80s, these kind of computers. And at the time, you had to be more grounded into what the hardware was doing, that when you pick up a big machines off the shelf now, you are fairly isolated. I think the Raspberry Pi may give people more of a chance of being more cognizant of what the hardware does.
Cool.
So Dan asks, can you explain in layman's term this is actually very interesting, what is managed code? And what aspects do you feel will change in the future? So we had a huge argument at lang.next about what is native code.
Yeah.
That's actually a really hard question. I thought it was easy.
So this is kind of the jewel of that.
Right.
How will it evolve in the future?
Yeah. So my strict definition of managed code is code that is checked both by a compiler and by a runtime to ensure type safety. To me, that's what managed code is all about. And I believe native and managed are not complementary. They could intersect. So it turns out that when we have a JIT, we execute code natively. At the end of the day, we have no interpreter. The native instructions, x86 or ARM, are executing up to a point when we need to interpose some kind of runtime call to a runtime because we want to verify type safety. For example, you do a cast, you do an array access, you need, for type safety, you need to make sure you stay within the array. You're not going to access off of the end of the array. So that's what makes managed code. With Mono, for example, there is interested pre-compilation. So Microsoft CLR has pre-compilation. It's done by what we call engine technology, which is a compiler that runs offline and produces some native code, native assemblies, and those native assemblies we keep in a cache. They are not the authoritative source of code, meaning that if you move and change your assembly, the IL assemblies, then we will consider the native code that was compiled from the older assembly just to be discarded. So it's not authoritative. To simplify the model, IL is what the programmer should care about, and if you replace the IL, automatically the native code that was compiled before goes away. You could consider a model where the native assemblies are the first-class citizens, and it's your responsibility to compile them offline and then deploy them. It's not something and that's kind of the Mono story. We haven't done that just because we didn't want to complicate the model for the programmers, where right now there is only one source of executable, it's your IL, and behind the scene we make sure that when engine is running, it's actually compiling your IL code into native code. And so at this point there is not, if you look at C++ executing RTTI code, the fact that it's unsafe, but there is a lot of runtime calls going on compared to the CLR executing an engine assembly. The difference are not so great. One will ensure type safety at all costs. That's the CLR. The other one will respect type safety only if the programmer has made sure in source code that type safety is verified. But that's kind of the main distinction that I see.
Interesting. And what about the notion? So in C++, Hans Bohm has written a rather good garbage collector. Not a lot of people actually use it, but garbage collection doesn't factor into your definition of managed?
It's necessary to ensure type safety, because if you delete your object explicitly, then you don't know if somebody else is actually not using it. So garbage collector is a precondition of type safety. That's one of the pieces that is needed. You need an automatic memory manager to make sure that the objects that are still reachable are still alive. And so you're not going to reallocate another object on top of the one that you believe is dead, but is still considered alive by another piece of code. In terms of Hans Bohm collector, it's adequate, but it's not very good, it turns out. And the main reason is that it's missing a lot of type information, And in particular, you cannot do a precise collection. So if you, on the stack, you have remnants of old pointers that are no longer active, but they haven't been cleaned up by the compiler, then these objects will stay live. So you have a fairly poor control over the lifetime, where the CLR will track lifetime very, very precisely. So if you use an object and you stop using it, then the point of last use is where we will consider the object dead, regardless of the fact that you are still executing code from on this method.
Excellent. Great question.
All right, so interesting. Is that this one?
Yeah.
All right, so Kareem, sorry if I pronounced it wrong. What are your thoughts on research on mathematical correctness in software?
Yeah. So I think it's a great avenue of research, and it's something that we learn from, and we incorporate as results become practical, more and more of its results. I can say, for example, the fact that you can verify statically Java code or .NET code that was compiled safely is a result of that research. And so verifying statically type safety in some conditions is practical. When it's practical, we can use it. In general, verifying correctness has proven to be very difficult. Microsoft, we use in C++, we use prefast prefix, which are a result of Microsoft research to verify some attribute of C++ safety. And we use that to try to detect buffer overflows, access to null pointers, dereference to null pointers that can be vectors of security attacks. And so it was interesting that the research group had a very deep framework that was extremely difficult and slow, and we gave them the challenge, make it practical, and we use it. And they made it practical for a fairly small subset of the general problem, but that small subset proves to be very, very good. And so it verifies only a small subset of what's going on, but when it verifies, then it's good. So I believe that the job of research is to explore kind of the larger problem and then find pockets of situation where it's practical to actually apply it, and then transfer that knowledge to the industry. And so I'm a big fan of that, but I must say that we just scratch the surface, and it's a little bit frustrating to see the amount of progress that is done every year, not that much in that field. And I know a friend of mine who used to be a vice president at Microsoft, retired, and for a long time we were talking about language safety and that sort of thing, and say, okay, I'm going to spend 2 years in a university trying to make that work, theoretically. And then I saw him 6 months ago, and he said, well, I spent 3 years and I gave up. And I'm not closer to a practical solution. And I had fun. I had 3 years of fun, but I didn't bring much with me that can be applicable to the industry. So I think it's a tough, very tough nut to crack. And I encourage research in this area. I think there is tons of good things, and then the nuggets we can apply.
Excellent. All right.
We already did this one. All right, so what devices do you see the CLR being ported to in the future? So right now we know we have it on the phone, we have it on desktops, various devices. I mean, not sure what other devices there's going to be, but for example, there's no CLR in our little nice phone here.
Well, we could.
We could, yes.
Because we have the compact framework for embedded, and so embedded is more than the phone. We have tons of devices in the wild that are not mobile phone that runs off of Windows CE, and so certainly the compact framework is still vibrant, and we are still investing in the compact framework. And then there is the tiny CLR, and if you look at the tiny CLR, I've followed and I have several tiny CLR devices at home, and what was interesting is that they needed quite a bit of memory, and so it's designed for microcontrollers, but most application microcontrollers are essentially, they have, if you look at the silicon, there is about maybe 20% of the area that is the microprocessor itself, the cache, and then the rest are blocks that are designed to be I/O blocks, such as SPIs, PWM, the pulse width modulation devices, timers, that are designed to be used by the designers to hook up to the real world. And then there is RAM. And now, since about 3 weeks ago, there is a new port to the tiny CLR, to a single chip that doesn't require an external RAM. That's the ST32MF4, which is a Cortex M4 processor that has about 128 kilobytes of memory usable of RAM and 1 megabyte of ROM. And these devices now are large enough to use to write projects, tiny CLR projects on it. So it becomes interesting because you can put this chip without an external RAM and control something. So it's kind of the Arduino. I'm sure everybody has heard of the Arduino line, where there is some kind of a variant of C++ you use, and those chips are very small, and you can do interesting apps. Now there is actually a new Arduino. What is it? I don't remember the name of it, that runs the tiny CLR. I think it's the Arduino. I actually don't remember.
On Channel 9, there's actually some coding for fun projects that use it. So folks out there.
So now there's a new version of Arduino that uses C#. Mm-hmm. So I see it's going at this point, and then we are going to be on the cloud. We may have to tweak the CLR to be best citizen on the cloud. We don't know that yet. What runs right now is the normal CLR, but in the future, we are certainly want to be a first citizen there.
So speaking of the cloud, since that's so fundamental and important in the future, what is this notion of, like, the massively distributed computing in the cloud? How does that impact your thinking as you develop? So let's imagine that I'm writing I have 50,000. I was reading an article yesterday.
Yeah.
There's a company that had used Amazon's cloud, but it doesn't matter what cloud you use. I mean, a cores. Yeah. So they had 50,000 cores, 88 terabytes of RAM to run massive computational stuff.
Yeah.
So how does stuff like that impact when you think about CLR?
Yeah, so I don't think it impacts the CLR too much. It impacts the programming model on top. What you need to go to an asynchronous programming model, and you need to, the flow of information is very important. So essentially you need to have good connectivity, and you need to segregate the amount of information that you need in order to do your task. so you can distribute and scale. So certainly the async pattern that has been developed for C#5 is a big player into that. But in terms of computing structure, what's happening is you try to isolate the computing structure, each node essentially away from each other, because on the cloud, you are not sure what is co-located exactly on the same server, on the same cluster, on the same, even at the limit on the same data center if you do your job right. And so MapReduce style of computing is where it's at when you have a large amount of data. And for that, it's based on having a certain amount of decoupling between the cores. And so the CLR itself, it becomes a little bit easier, if you like, than the server. The server is where it's the harshest. When you have a symmetrical multiprocessor and you have 128 cores, and they all need to be in lockstep because you want to have a tight coupling between them, you share the memory. So in a way, I believe that the cloud computing is easier on the what we want to do is we want to be more efficient on single core then.
Sure. Now, what about garbage collecting 88 terabytes of RAM?
Well, you don't. There, you collect individual nodes, so the task is somewhat easier because you don't share that amongst all the processors.
Cool. All right, so let's ask some more questions here. You want this one?
Yeah. So we already talked about it. Mono had support for calling SIMD operation.
Yep.
And it's great. And I believe it's great. And I said we don't have that. We had a prototype. There is a prototype on Microsoft Research.
Yep.
I believe it's called Accelerator, by the way. So you can look it up. You go on the Microsoft Research site and look for Accelerator. So we had a project like this. For various reasons, we are too busy. We kind of passed on the productization of it. And that's something that we do care about, and something that at some point in the future we'll do something about. But I can't give you any timing.
But for now, the C++, VC++11 has an auto vectorizer, which you guys should check out if you write native code at all. It's really interesting technology. Okay, so we're going to now go to, this is an interesting one. I don't know if you have the answer to the WinDebug and SOS DLL.
I don't believe it's possible.
Okay.
To use the Windows Phone 7, because WinDBG, I believe, doesn't have the transport mechanism to go debug on the phone. Just to let you know, the CLR has essentially two avenues for debugging. There is the managed debugging that uses some infrastructure. That's what we use for the Windows Phone 7. And WinDBG is not hooked up to that. WinDBG uses the normal NT OS debugging capabilities, which are supported by OS calls. And the CLR is fairly passive there. What we did is we wrote a library, helper library called SOS, so we can reach into the CLR data structures and expose them to the debugger extensions. But it's not available across reaching into the device.
So here's a question from Sunny. How come you don't mention object lifetime management in your managed code definition?
Oh, yeah, I should have. When I say type safety, if you explode the type safety concept, what it is about, so type safety is about having compiler language support, so you cannot mix types on the same location like C does. And so it's illegal to, when you have an int, to dereference that as a object reference or do the opposite. And then the second part is the runtime part. You need to have a automatic memory management, object management. So every object you can still accessible from the code is maintained live, and that's the second part of type safety. So yeah, type safety necessitates an automatic memory manager. So you allocate, but you can never delete explicitly. The programmer cannot decide when an object should be dead.
Good question, just to clarify that. All right, Dan's asking, isn't IL code precompiled into native code specifically the processor it's running on? Doesn't that tend to make it more efficient? That one's simply targeted x86 architecture. So
in actually, yes, the engine looks at the exact processor, and in theory it can be more efficient. However, the x86 flavors tend to be fairly uniform, and so it's something that we worry less and less. In the beginning, CLR 1.0, we can say, hey, if some floating points, are slow, can we go and call, something else instead? But then Intel and AMD have very similar execution profile. So at the end of the day, we don't have much. We don't take advantage of the fact that we know the precise CPU we are running on. Something that Intel approached us at some point, they say, hey, if we add 15 more registers, could you, in your JIT, take advantage of all more registers? Say, yeah, we could, yeah, that's something that would be doable. And so we said, yeah, we would be interested. And then the fact that most of the applications are still, C++, the OS is C++, SQL Server, and once you don't have that luxury, in C++ doesn't have a just-in-time compiler, so the fact that C++ wouldn't be able to take advantage of it because the OS was not willing to issue one image per processor kind, made Intel back off that plan of having more registers for some of their processors.
Interesting. Very cool. All right, so we're winding down here. Peter, can you tell us more about the role the CLR will play in Azure? And any significant changes that may come about the way it works? Because of the difference in architecture.
Yeah, so I talked slightly about this, but certainly on Azure, most of the server workloads are managed. I mean, it's ASP.NET, it's SharePoint, all the extensions we have, Outlook, the extensions are managed. So we see managed code to be the primary workloads we are going to execute. And we are opening Azure to other runtimes. So Node.js works on Azure, the Java VM works on Azure. So other managed languages are there too. As I said, right now we believe we are doing a good job with the server CLR when we run on Azure. We are going to look more deeply, and we may tune the current CLR or kind of derive some CLR versions just designed for Azure. Once we have enough data and we can fine-tune the architecture. That's something we are looking at. So far, nothing very exciting jumps out, but what may jump out is the fact that you have only one core, but you are on a server. So right now we have two variants of workloads. We have the server workload, which right now is mostly MP, symmetrical multiprocessors. And then we have the workstation that is mostly interactive. And you could think of a server workload that is not interactive, that has high throughput requirement, but execute on one core. So that may be one way to slice the cake for Azure, but that's not clear yet.
Okay. So what high performance improvement do you see coming? I guess in CLR.
So we talked about all you guys, I mean, have as many ideas there as we do. Certainly vectorization, using running on GPUs would introduce some quantum leaps in some specialized workloads. That's something that's sure. In terms of memory management, I talked to you guys about what we are doing and what the goal is. The goal is to have more and more memory, less and less latency, something that we talk about. And in terms of every library, the stack, network stack, will take advantage of faster networks, certainly if we can. But that's about say all the question you ask, there is a component of what architecture after all changes we can take advantage of, and everything we can improve will improve.
Great. All right, so we have a few more questions here. What do you think you will want to work on the most in the future? You yourself.
So myself, I said I'm a runtime guy. I mean, that's kind of my passion. So CLR being a runtime, GC is a subset of this, and I've handed off the main task of developing GC to Maoni Stevens. She did at least 2 or 3 talks at some PDCs. She has a blog that is it's probably the top blog in GC in the industry. And so I've been involved in more higher level, what do we do next generation, what do we do? .NET, the .NET ecosystem is something that I care deeply about. So I'm the chief architect for the .NET FX, and I've been involved in trying to make Silverlight and the phone and Windows 8 as similar as possible. That's something we introduced the version 1 of the portable assemblies definition. We'll introduce the version 2, and so I'm very, very keen on having a common subset that works everywhere on all of our platforms, and that's something that I follow along. I care about the .NET libraries to program in Azure. That's something that's right now the Azure team is responsible. I would like to have some of our .NET FX team also take a shot at it. So that's something that we are very interested in. So that's kind of my core passion is this.
Just had a thought about the future of the CLR roles and parallel processing and what changes we will see in multi-cores, grid computing, and similar scenarios. So that's from Peter Shaw.
Yeah, so that's kind of what we were talking about. I believe the future is, so there are 2 kinds of future. Before we had mainframes and computers.
Yeah.
And then you say, all the small, servers are going to displace the mainframes, and then every time say, the mainframe is going to go away, and the mainframe, by large, its influence waned, but never went away. I see a parallel between large SMP machines and grid computing, which is isolated, smaller computers that are linked by high-speed networks, high-speed interconnects. And my opinion is that the big machines that are going to wane because they become very expensive. And if you look at the scaling, when you have a 4P machine, the cost is really small. I mean, 4 socket machines, sorry, 4P, now every socket has 4 Ps or more. But in terms of, so there will be multiprocessors, but the number of sockets on machine is going to stay fairly low because for grid type computing, the price points favors a fairly small number of sockets, like 2 or 4, or 1. And so in terms of SMP, the number of processors, there will be class of machines that have more and more processors, and then a class of machines that have a modest amount of processors, maybe 16, maybe 32, and that will stabilize. But what counts there is the fact that they need to have connection in order to group them and to do the kind of computation Charles was talking about. And so I see that evolving, and I see us having to serve those two environments. And so certainly the future of computing, I would predict, will be more a reasonable number of cores, and then linked with interconnect that is fast interconnect, as opposed to SMP machines. But then SMP machines are not going to go away, I believe. And so we'll have, I believe they are the mainframe of tomorrow, the big SMP machines, and then the kind of the grid computing being the future of large scale computing.
Sure. Now, speaking of the future, what about what's clearly the case is the sort of explosion of low power devices.
Right.
How does that impact your thinking as you move forward?
So I think the impact there is we need to have a very good CLR that is as modest requiring monitor resources. And certainly the phone, Windows Phone 7, has a different CLR than the CLRs that are on the desktop. That's a goal of us to actually go down and be able to serve phones in the future with the same CLR architecture. So one of my passion as well is to how we can make the CLR smaller and smaller and more efficient on small form factors.
Great.
All right, so we're
going to run out of time.
So we're getting ready to run out of time here, gentlemen. We're already at an hour and 42 minutes.
Actually, we're an hour and 20 minutes. We've still got 7 more minutes.
Okay, so
yeah, I have a hard time. I'll stop at 10:30. I need to be out of here. But that's
all right. So
do you want to just call it, or do you want to answer another question?
Optimization.
Let's talk about compiler optimization. So.
Yeah, so a long time ago, I patched a new buffer algorithm into a database, and we never managed to make a compiler to produce code as efficient as handcrafted. I think that's that has been an ongoing battle from the compiler side or debate on the programmer side. Can you generate code as efficiently as handcrafted? And just to remind you, for a long time, Excel had its main calc engine written in assembly code. I know the x64 version of Excel doesn't have it anymore. I don't remember about the x86. But the reason is that that code was small. So I believe that compilers, they rarely get tired. They can generate a large, megabytes and megabytes of object code with good quality. A programmer can only optimize few hundreds of lines of code. If you compete 10,000 lines, very difficult. 1,000 lines, I think, is a hard limit. So when you have a tight loop, a type loop has, 200 lines and you really, really want that 2% efficiency, then assembly code usually will win. Some experts in compiler can tweak the compiler declarations and pragmas to actually get close, but at the end of the day, it's as difficult as write the assembly code sometimes. So, but on big scale, on large scale, then usually compilers win because people make small mistakes and they cannot compile in the large. You cannot write everything in assembly code. So that's the reason why we code in x86. I mean, we code in C++ and not in x86 assembly. It's true as well for ARM, and so you can project that between C# and C++. Hey, how come I can never get C# to be as efficient as C++ when I look at the generated code? And that's true mostly because our compiler technology is derived from the JIT, and the JIT needs to compile the code very quickly because the code is about to be executed, so you need to compile it quickly, where the C++ compiler has more time and more memory to devote to the compilation. That's certainly an avenue of exploration. Is if we were not bound by the time constraints, could we generate better code? And we believe we can. I also believe that right now we can manage memory, manage objects a lot better than C++ can, and that's why the workloads, the server workloads are, you can't barely find any C++ workloads there because C# is easier to write and you get as efficient workloads. Doesn't mean that the instructions are as efficient, but globally, when you look at the fact that we can recycle memory a lot faster than a normal allocator can, goes in our favor there.
Sure. That's a good point. But that does lead to a question about NGen in general. So if I use NGen.exe before, I don't want my stuff to JIT. I'm going to NGen it up front.
I know, so that's huge. Right now, we don't take advantage of that, but we should. That's one of the areas we're looking at.
All right, we'll take one more question. Patrick's got to run.
Hey, I've got to know. I just have to know, Patrick. You are a math geek, right?
I'm not. I just barely know enough math to be dangerous in algorithms, but in general, I'm good at arithmetic. I believe that integer arithmetic is a fascinating field, and the better you are, actually better code you write. So that part I'm pretty good at.
Can you just answer yes or no if you know about the mathematical foundation at Rice? I'm really curious about that.
No.
You know nothing about this generate mathematically correct software from a spec thing?
Not from the Rice. I know some efforts, but I don't know this particular one. And I think it's a very intriguing automatic code generation based on algorithm specs is certainly something that is interesting. We do have some technology on Microsoft Research that where we generate tests automatically based on test specifications, and we did use that to verify the specification we sent to the European Union for the documentation of our protocols. So the research group actually gave us a tool. So we based on the specs, we generate a test spec, and then we generate code automatically, and it verifies that the implementation essentially corresponds to the spec. So I'm a firm believer of these kind of things.
Right on. Well, that's just great. Well, I guess it's time to end this meeting, and we really appreciate it. and talked a little bit more at the end here. Let's see. What else do I have to put up here? I think I'll leave it on this page here with the links